The modern business intelligence standard is defined by scale and aesthetic perfection. Organizations deploy heavily engineered dashboards loaded with vibrant gauges, intricate geometric models, and dense streams of real-time data. The expectation is that this level of visual density will provide executives with total operational clarity. But in practice, staring at these pristine interfaces often results in hesitation and confusion. This chart plots visual complexity against decision fidelity. The relationship is inverse. When a BI system is poorly planned, scaling up the visual density causes a sharp, non-linear plunge in a user's ability to extract an accurate insight. A dashboard's aesthetic appeal is irrelevant to its actual business value. Vibrant colors and intricate chart selections do not generate revenue or correct supply chain errors. The only valid metric for evaluating a business intelligence tool is its ability to force a swift, strategic business decision. Most organizations fall into the trap of building informative dashboards. These are passive systems. Their only function is to report the historical state of the business, to tell you exactly what happened up to this second. A decision-driven model is an active system. It is engineered specifically to map causal relationships, explaining why a trend happened and highlighting what operational lever to pull next. Here is a split-screen architecture applying the exact same dataset to these two distinct models. On the left, the informative approach fills the layout with overlapping lines, pie charts, and gauges. This architecture places the entire analytical burden squarely on the end user. The executive is forced to manually synthesize the noise, correlating variables across completely separate visuals just to find a starting point. On the right side, the decision-driven architecture strips the data down. We have one prominent trend line, a brief text explanation, and a single actionable vector. The streamlined model immediately identifies the anomaly, details the root cause in the text, and provides an active button to resolve it. The system does the synthesis. Transitioning from an informative trap to a decision-driven engine requires dismantling three specific, highly common architectural failures. The first flaw is KPI saturation. This stems from the false assumption that giving a user more data will automatically yield better insights. Human cognitive bandwidth is finite. A flood of simultaneous metrics triggers analysis paralysis, freezing the user's ability to isolate the single variable that actually demands immediate action. Take the case of a large retail chain. Their critical operational need was to track localized regional sales data to execute targeted promotions on a weekly basis. The interface is packed with disparate metrics, massive global revenue aggregates, sprawling demographic breakdowns, and broad supply chain totals. Buried in the bottom corner is a tiny plummeting line graph representing a severe regional sales dip, completely camouflaged by the visual clutter. A dashboard must be designed to aggressively filter out noise. It is not a dumping ground for every available metric in the data warehouse. Adding KPIs without scoping them to a specific action destroys the tool's utility and results in measurable revenue loss. The second flaw requires looking past the surface UI design and examining the underlying data architecture. The latency failure occurs when slow back-end performance actively destroys user trust. A pristine visual interface cannot compensate for a tool that takes minutes to load. This node map illustrates the mechanical root cause. When inefficient semantic models attempt to query massive, unoptimized databases simultaneously, the data pipelines bottleneck. Consider a healthcare organization managing patient flow. The medical staff requires instantaneous access to incoming triage data to allocate beds. When their dashboard lagged due to heavy, unoptimized queries, the end result was total and immediate tool abandonment by the staff. In dynamic, high-stakes workflows, users will classify a visually stunning but structurally slow dashboard as fundamentally broken. Severe query latency forces users to bypass BI governance entirely, reverting to analog intuition and manual reporting out of pure necessity. Imagine a theoretical scenario where the engineering is flawless, the UI is remarkably clean, and the back-end queries resolve instantly. The system can still fail if it suffers from an alignment failure. This happens when a perfect data architecture is completely decoupled from the specific, actionable business objective it's supposed to serve. A financial firm deployed a new dashboard with a strict strategic mandate: identify aggressive, short-term arbitrage opportunities in dynamic markets. This sleek interface presents sweeping macroeconomic indicators like GDP growth and long-term inflation curves. But look at the firm's actual target parameters for short-term arbitrage. The broad market curves completely bypass the strategic objective, offering zero utility for high-frequency, short-term trades. This highlights the absolute necessity of a strict feedback loop. A static dashboard in a dynamic market becomes entirely obsolete the exact moment the company's operational strategy inevitably shifts. High-fidelity data delivered without a targeted strategic inquiry is just expensive trivia. Having deconstructed these failures, we can now engineer the ideal high-fidelity BI end state. The solution begins at the back end. Modern environments like Microsoft Fabric reduce latency by consolidating fragmented data streams into a unified one-lake architecture, minimizing the complex data movement and transformation steps that usually slow down performance. This diagram shows the optimized pipeline. Raw data blocks funnel seamlessly into the Fabric node, feeding one efficient semantic model. That model pushes directly to a minimalist UI. Here, AI tools deliver a natural language synthesis of the data spike, paired with a single approval button. These capabilities shift the heavy lifting of data analysis away from the executive. The machine determines the why and recommends the what next. Advanced Power BI features should never be used to stack more visual noise onto a screen. They exist so you can ruthlessly edit the dashboard down to the single most important action. The primary mandate for BI architects is strict. You must start at the end. Work backward from a predefined, singular business objective. A successful deployment requires pre-constraints, exact objective scoping, relentless query optimization, and extreme UI reduction. Think of the architecture like this. The specific business objective is the massive bedrock layer that supports the thin, refined UI layer sitting on top. Audit your own organization's BI implementations against this objective-first framework. Look closely at the screens your teams rely on and ask, do these dashboards merely present an attractive illusion of control, or are they engineered to force strategic action? True mastery of data storytelling is found in the discipline to strip away the noise until only the catalyst for action remains.